Hello, welcome to another CleaveTech tech tip. And today we're going to look at a bit of slot car history. We have this quite old-fashioned controller here in front of us that is used as a thumb controller. Now these used to be really popular in the UK for many years, sort of 60s onwards I think. But this one's been in regular use and it needs a bit of a service and a little update with some extra features. So that's what we're going to be doing today. So without much further ado, let's get on with it. Now I'm not sure of the exact history of this controller, but I do know it's been around a long time. You can see the make of controller, it's actually an ECE, an ECE Rocket. Now I believe these were made, again, I might be corrected. If you know any more facts about them, please put it in the comments below. But I believe these were made by Tony Condon and Ian Fisher back in the day. And these were really popular in the UK, 80s, 90s, even in 2000s, people were still using these regularly. Nowadays, most people have switched over to what we call the modern controller, where you use your fingers on a little trigger. But back in the day, these were really popular. People used to like to use their thumb to control the controller and the movement of the controller. But your thumb is actually probably slightly slower to move than a finger. So, finger was obviously the better choice in the end. But because most people grew up with sort of like slot car home sets and so on in the UK having thumb triggers or thumb controllers, people got used to that and tended to stick with this method. And that was the only method they knew. So they were more comfortable driving with this sort of thing. So I've got this one here from, I'd say an older slot racer. He won't mind me saying that. He's been around a few years. He's won quite a lot in his time, a very successful UK and international slot car racer. But he still wants to keep using his thumb controller. He still likes using it, but it needs a little bit of a revamp and an improvement here. And that's what we're going to be working on today. Now, giving the controller a bit of a check over, there are a couple of immediate issues I can see. Hopefully, if I sort of hold that in the camera there, and I'm pushing this plunger down, have a look at the circuit board along here, and you can see how the tracks on the circuit board have started to wear out, especially at this first end here, where the lower movement of the controller, where you're always doing this bit in the lower bands of the controller, you can see how it started to wear through. Now, I can probably do a bit of a fix on that, I think, because this circuit board here was actually one that I made many years ago for these controllers. And you can see it's got a slot in here. So I might be able to actually loosen this off, slide it along a little bit so it runs on a different part of the circuit board, and then I can patch up those tracks that might be broken. But I'll have to get a multimeter on those and test those. So that's an immediate issue. There is a bit of an issue in that maybe the wiring needs a little bit of tidying up. If I move away here, you can see it's a little bit of a mess here. It's got some really good quality wiring, so at some point it's been rewired in the past. This Palmer wiring is pretty good. And then it comes down into this control box here. Now, I haven't tested it yet, but I've been informed that probably the transistor has blown because it only works on flat out. And then so we've got this nice wiring here. And then this nice thick wiring goes down into this really thin, what looks like some lighting cable here, which is clearly not going to carry a lot of current. So there's no point having nice thick wiring here and then really thin wiring here. So this wiring's probably going to need to be replaced. It's also gone a bit stiff as well over the years. It's not as flexible as it could be. And again, customer also wants a relay installing, a full power relay, again, which is going to help the full power, but probably is suffering more because of this really thin wire than actually needing a full power relay. Again, there's no point putting a relay in here when you're conducting all your current through this really thin wire as well. So I'll see about upgrading all of those. I'll give it a test, see if the transistor's working or not, and then I'll be able to repair the board and go from there. Okay, so I've just wired this up just to do a bit of a test. So coming from my power supply, I've got coming in here the positive and negative. So this one goes to the brake connection on our UK plug, And if you haven't seen my video on controllers and wiring before, I'll put a link up here to my playlist for controllers, and you can see all the work that I've done on controllers in the past. There's pictures of the circuits and so on that I use for controllers. There's actually a picture of the circuit for this controller here as well on those videos, so take a look through them. But I've got my power supply coming in here. The black's the brake. This is the power coming in. This one's the power coming out of the controller, and of course back to the negative or the brake wire of the controller. And then I've also connected this just to an old motor. Here we are, just to test to see what do I actually get working on this motor. Well, as you can see, if I hold that on there, as I move the controller, I get the motor rotating. But if I move it slowly, hopefully you can hear that in the video, I'm getting different steps of movement on the motor. Now that says to me that the transistor is working fine, because the way the circuit works, it works by, as you're squeezing this trigger, or sorry, as you're pushing the plunger down on the thumb controller, it changes the current going into the base of the transistor, therefore turns the transistor on more or less, depending on which way you're going, and that can adjust the speed of your motor. So as I'm pushing this down, you can see it starts about there. So have a look at the circuit board on the controller, and I've got some power about there. And then as I push it down a bit further, you'll hear the motor speed increase. And then it stops. So my guess is it's probably the fact that the circuit board is all worn out there that might be causing some issues with getting the current to the base of the transistor and turn the transistor on. So actually it could be the worn out circuit board that's meaning that the controller is not actually working on those lower bands there. So I'll have to take the circuit board out, measure that with a multimeter, test it and see if that's the case, because I'm pretty sure the transistor is still working fine, which is good news. Okay, so I've removed the circuit board from the controller, and I can see now that it's not actually one of mine. I'm not too sure who made this circuit board, but it's got initials on it. So if you're watching my videos and you made this circuit board, let us know in the comments below if you can, if it's your circuit board. But it did look rather similar to mine, because mine had these little surface mount resistors and so on when I made it, but it's not my version of circuit board. It's been replaced probably since then. I say I made some many years ago for these, but you can see it's still quite worn across here. So what I'm going to do is I'm going to take a multimeter and I'm going to test the connections, and we're going to see where we go from there. So I have my multimeter and I have it set to continuity test, which is a little picture of a diode. Sometimes it has a little picture of a speaker or three sort of curved lines to show it's going to be an audio signal, because some of these multimeters you can get that make a beeping sound. But I'm just basically going to test the connectivity of these tracks and see which tracks are broken, which ones aren't broken. So let's put that together now, and then I will test it out. Hopefully you can still see that. But if I put this connector there and there, either side of that dodgy area, you can see that the meter changes and I get virtually no reading, which is good. Let's try the next track. Again, that one's connects, this one. That one connects. Yes. Yes. So actually it's looking, although they're very thin and nearly worn, they're not actually broken. But they're not going to last very long anyway. So they're going to need a bit of a repair, if I can. But looking at this, all the tracks themselves seem fine. Yep, all the way right down to the bottom. So every single track on there still has connectivity or conductivity or continuity along the track there. None of those little tracks there where we thought they looked pretty dodgy are actually broken. But what I'm going to do anyway is I'm going to run some solder across those tracks, and as I said, I can probably move the board a little bit so that the wiper of the controller runs on a different part of the board. So it should have a much longer life than putting it back exactly where it is and then wearing through those tracks very, very quickly. But I hear you say that doesn't explain why it only works on the last few. If all the tracks are fine, why does it only work on the last few bands? Well, I don't know yet. So the next thing I'm going to need to try is the connections on the resistors. I know the tracks are going to be fine. I know the tracks are all connected, but is there some sort of dodgy solder joint on any of these resistors here? I don't know whether you can see. If I get up close, you can just about read them. They say on the resistor 27R0, which means that it's a 27.0 ohm resistor. So each one, looking at it, is the same. Looking across everyone's a 27 ohm resistor. So it should go up in steps of about 27 ohms. Now, the OCD part of me says, well, I don't know why that one's upside down and that one's up. They're not all the same way around. It doesn't matter with a resistor at all. I'm just picky, and I would get the writing the same way around on all the resistors if I soldered them together. But I'm not going to go back and change them all now. I can just about manage to live with that. But I am going to check the conductivity through the resistor and the resistances to make sure that there is still a connection through each band of this board. So we come back to the multimeter, and I need to set the multimeter this time to measure resistance. So that's this scale here. Now, I know the resistors are only going to be 27 ohms each, and there's not that many of them to make up a total resistance, but if I needed to go higher, I could go to up to 2000 ohms. But I'm going to stick on the smallest scale to measure as accurate as I can on the 200 ohm scale. So I'm going to put that onto there, and then I'm going to start testing it bit by bit, going down and seeing if I get a connection through, and then where there might be a problem. So let's start here right at the very top, and then we'll go to the next band there. So between that one and that one, I'm not getting anything. I'm not getting any connection between there and there. It's a bit odd. So has something gone dodgy with this connection here? Is there a problem? Let's measure across that resistor. See, do I get anything across that resistor? Nothing there. But obviously if I touch the probes together, I do get a connection. So there's something going dodgy here, I believe, between that resistor and there. So there's no connection there. What about between that track and that track? What's my connection there? Okay, so the meter's measuring 28.2 ohms, which is probably acceptable, bearing in mind there's some tolerance on the meter. They're not very good at measuring really low resistances, these types of meters, but it does tell me there's a good connection between those two tracks. So then we go to the next two tracks. Is there 27 between there? No, so there's no connection between there and there. That's a bit dodgy as well. What about between those two? So there is there connection between those two. Is there between these? Yes. Connection there, but no connection again there. Remember, it only started working when we got to these last 3 or 4 bands of the controller. I don't know whether it was the last 3 or last 4 bands, but there's no connection there. But there's a connection there. There's a connection there, and one to the last band there. So in order for the controller to work, there obviously needs to be continuity between the whole lot, and it needs to build up like a whole sort of resistor network in line. So clearly with a couple of breaks in this circuit here, that's why it only starts working when it reaches the bottom of the controller band here. So, or the wiper bands there. So I need to have a look at, maybe I'm just going to reflow the solder on this resistor. I don't know. Let's put the meter on the potentially the suspect resistor here. Actually on the resistor itself. Yeah, see, I'm not getting any connection there at all, even on that resistor, which is unusual because normally if resistors blow, well, depending on what type of resistor they are, but this one's not got any connection between the two at all. So I might just reflow the solder, see what's happening there. If that doesn't fix it, then I might have to replace this resistor here on this end and see what I've got in my box to replace it with. I'm going to get my soldering iron out, I'm going to repair this, and I'm going to reflow the solder joints on the resistors, and then we'll test it again. So I've got one of these little mini abrasive blocks here. They're a bit like the old ink erasers you used to have when you were back at school back in the old days. That's showing my age a bit really, but we used to have like ink erasers. They're a little bit like that, but perhaps a little bit more rubbery. Again, if I can find a link of where you get these from, I'll put a link in the description of the video below where you can get them from Amazon perhaps. But I've just given it a little clean up here across the circuit board just to make sure the solder is going to stick nicely and repair those tracks the best I possibly can. So I've replaced my trusty 5mm tip in my soldering iron with a small sort of fairly pointy tip because I'm going to be doing some fine electronics. I've also got some normal 6040 tin lead solder. That is 22 standard wire gauge, not American wire gauge, standard wire gauge. You can look the conversion up on Google, but if I get a chance, I'll put a little thing on the screen in a moment for the conversion. But this has got some sort of flux core inside it, which just helps the solder stick to the circuit board. So I'm going to start repairing this board now.
A little longer than a few minutes later.
So here we have it. I've gone through and I've patched up all the bits of the circuit board that were thin before. In most cases, I've had to put a little piece of wire over the top of the circuit board just to join it up because the solder wouldn't really bridge the gaps very well. But as I say, it wasn't totally worn out. There was continuity there, but so it probably would have been okay, bearing in mind I'm going to run the wiper on a different bit of the circuit board. But I decided I'd just go sort of belt and braces on that and make sure it was fully connected. Now, the issue I had here, when I reflowed the solder on these resistors, I still couldn't get connectivity and continuity through the little surface mount resistors on those places, on those three dead spots or three places where I couldn't get a meter reading. So I've had to replace the resistors. Now, I didn't have surface mount resistors. I only had these very, very small through hole mounting resistors. But they're pretty close. I mean, they're 27 ohms on the board, and these were 22 ohms. But when you're actually driving, I don't think you'll notice that difference too much in the steps of the controller. So I think that'll be fine, and that was as close as I could match. But at least it's going to bring the controller back to life again. So just to show that there's continuity throughout the whole board now, I've set my meter to the 2000 ohm scale. And I'm going to be putting one probe on the first track and one probe on the last track. Yeah, 336 ohms in total from the first track to the last track. Okay, so I put it all back together now, and I've just wired it in again just to do a quick test. You can see now how the motor starts to move on the very first band now. And I've got movement on every band of the controller. And then I put it all back together and it stopped working with lots of swearing, etc. But I finally found the problem.